All right, let's look at the second possibility. So we found one here. We decided this value here was going to be, where was it actually? Sorry, I've lost a bit of paper I wrote on. Negative 25 over 16. So that intersect there is going to be negative 25 on 16. And that was the y-intercept. Now let's find the y-intercept for this here, where we've got that line with a gradient of 1/2 intersecting with this parabola at only one point. And let's find out what that would be. So here we go. So I'm going to write out this equation. I'm going to write this out, this equation with a plus k on the end. Because we don't know the intercept, we're going to let the equation play out and see if it can suggest something for us. So let's go ahead and do that. So here it is. So first of all, the original equation is y is equal to negative 1/2 x squared plus 2x minus 4. And that was that larger parabola. Then we've got, or that broader parabola, I should say, y is equal to 1/2 x plus k. Now, we don't know what k is, and of course it is going to be negative, but I don't need to put negative here. Plus just means and. We're going to find out how that works. So let's make these two equal to each other in the same fashion as before. And I'm actually going to put make this an x squared on 2. I don't like it. This an x on 2 as well. So let's do that now. So this is going to be, and I'm going to put negative x squared on 2, rather than saying negative 1/2 x. I just find this slightly more succinct. Plus 2x minus 4 is equal to, and I've got this here, which I'm going to say is x on 2 plus k. So first of all, I can see I've got 2's everywhere. I'm just going to multiply everything by 2 to get rid of the fractions. So if I multiply this by 2, and this by 2, and this by 2, this by 2, and this by 2, and it doesn't matter at which stage you do this, but I'm just going to do it now. So I'm right from the outset, I'm going to continue the way I want to. Continue the way I want you to start. Or yeah. So let's have a look. We've got 2 divided by 2 leaves me with a negative x squared. 2 times 2 is plus 4x. 2 4s negative 8. The 2 and the 2 here cancel, leaving me with an x. And I've got a plus 2k over here. So now I'm just going to subtract x from both sides. Here it is, subtracting x from both sides. So this is now going to be negative x squared. 4x minus x is going to be plus 3x. What else we got here? Minus 8. I'm going to subtract 2k from both sides. Minus 2k. Minus 2k is equal to 0. Now let's go ahead and I notice I've got a negative x squared. I don't really like that. And to be straight up with you, I've got a lot of negatives here. I would actually just prefer to multiply everything by negative 1 and just deal with an x squared rather than negative x squared. It does not matter though. We can deal with it the way it is. I just stick. I'm going to do that. Let's multiply everything by negative 1, by negative 1, by negative 1, by negative 1, and by negative 1. Just because I don't want that negative x squared. It doesn't matter, of course, but this is going to now become x squared. This is going to become minus 3x. This is now going to be plus 8 plus 2k is equal to 0. Now, am I happier with that? Yeah, not really. It's just... But now, again, we've got the same situation irrespective. We want to go ahead and we want to solve and find out what x would be if there was only one point of intersection, but we can't because we've got a non-numeric value as part of the coefficient of one of the x terms. So we've got this x term as a coefficient of this case of 1, so a is equal to 1, b as a coefficient of negative 3, there it is, negative 3, and c has a coefficient of 8 plus 2k. So, but we have a non-numeric coefficient. And then when we do that, to resolve a non-numeric coefficient in a quadratic, all we do is we just use the discriminant function to resolve the issue. So let's go ahead and do that now. So I'm going to say the b squared minus 4ac. Now we know it's going to have one point of intersection, so it's going to be equal to 0. I'll put equal to 0 way over there, because I'm going to have a whole bunch of stuff going in here. So b squared, that's going to be minus 3 squared minus 4 times a is 1 and times c, which is 8 plus 2k is equal to 0. So negative 3 squared is going to be 9, minus 4 times 1 is 4, times 8 plus 2k is equal to 0. Let's expand out the bracket. So I've got 9. Negative 4 times 8 is minus 32. Negative 4 times 2k is going to be minus 8k. All right, so now very, very simple. I'm going to take that 9 and I'm going to subtract 32, which would leave me with 9 minus 32 is going to be negative 23 minus 8k is equal to, back to zeros, we need some zeros here, folks. So let's now add 23 to both sides. I'm going to add 23 to this side. I'm going to add 23 to this side. So I've got minus 8k is equal to 23. I'm going to divide both sides by 8. Divide by negative 8. So k now is equal to negative 23 on 8. And I'll put the negative on the top. It doesn't really matter either way, but normally you would. So that is the k value. That is the value which the y-intercept would be for the line, which is y equals 1/2 x. You add on the negative 23 over 8, and then what you've just found is you found the y-intercept for a line which will touch this parabola at only one point. And that's what we've found. So this line here now would be y is equal to 1/2 x plus, minus 23 over 8, minus 23 on 8. And the line over here is the other one, what's it? Minus 25 on 16. So that's going to be y is equal to 1/2 x minus 25 over 16. And that is what we found.